Welcome to Logarithmic Differentiation, derivatives using logarithms. Logarithms are used to make finding the derivative of some difficult expressions easier. It's a good idea to review the properties of logarithms. I'll pause here a minute to let you read over the slide. Here we will use base E, so we can write the rules using base E, a natural logarithm. Find the derivative of y of x with respect to x, where y of x is the square root of the quotient of x squared plus 5 over 2x cubed plus 5x plus 1. The technique is to take the logarithm of each side. The logarithm of y equals the logarithm of the square root of the entire expression x squared plus 5 over 2x cubed plus 5x plus 1. Then it's a good idea to rewrite that radical symbol as a 1/2 power. Using the laws of logarithms, we can take that 1/2 out and make it a multiplier of that logarithm. Now we take the quotient and we use the rule for the quotient to make it the difference of two logarithms. So we have 1/2 the log of x squared plus 5 minus the log of 2x cubed plus 5x plus 1. Then we differentiate both sides of the equation. We have to be careful here. We have y of x. It is not x. We have to use implicit differentiation. So the derivative of the log of y is 1 over y. But we also then have, through the chain rule, the derivative of y with respect to x. That's equal to 1/2. Then we take the x squared plus 5 as the denominator, and the numerator becomes the derivative of what's inside. So it's 2x over x squared plus 5. Likewise, the 2x cubed plus 5x plus 1 becomes the denominator, and we have to take the derivative of what's inside, 6x squared plus 5. This is the chain rule. We have to take the outer form, then the derivative of the inner form. Finally, we have to multiply both sides by y of x because we do not want 1 over y dy dx, we want dy dx. So we multiply both sides by y of x and substitute the original expression back in for y of x. Another use of logarithms is finding the derivative when x is in an exponent. Here we have find the derivative of 4 to the x power. So we'll let that equal y of x. Again, we take the logarithm of each side. The log of y of x equals the log of 4 to the x. And again, we can look at the log of 4 to the x as x times the logarithm of 4 using the power rule. So we now have the log of y equals x log of 4. Remember, the log of 4 is just a constant. differentiate with respect to x, and again, we have to deal with 1 over y, the derivative, the log of y, but then we have the derivative of the y itself, dy dx. On this side, the right-hand side, the derivative of x is 1 times the constant, and the constant in this case is the logarithm of 4. Again, we have to put the y of x back in to cancel that 1 over y of x. We have to do it on both sides, so the derivative of 4 to the x over x is 4 to the x log of x. Usually we find out very early in calculus that the derivative of e to the x is itself. So let's go through the calculation. Take the log of each side. Log of y of x equals log of e to the x. Again, we pull the x outside, so we got the log of y equals x log e. In this case, log of ln e, the natural log of e, is simply 1. So we have 1 over y dy dx equals the derivative of x is 1. Multiplying both sides by y of x, we get dy dx is y of x, which, if you recall, was e of x, e to the x. Now it's possible to generalize and say d dx of a to the x is the log of a times a to the x when a is greater than 0. We have to remember that in all of this work, whenever we take the logarithm, we have to assure that the log is not of 0 or a negative number. Make sure the logarithm is always well defined. Well, we can make the problem a little more difficult by having a function of x raised to a power that's a function of x. Let's look at this one. Y of x equals 3 to the x squared plus 1 raised to the 4x cubed. We can take the derivative with respect to x. A lot of students would like to just subtract 1 from the exponent, but that is not the way this works. We take the logarithm of each side, and again, we bring the power down. In this case, it's 4x cubed. Then we will take the derivative of each side. So we end up with, again, 1 over y dy dx, just like we had been doing in the past. On the other side over here, we end up with the derivative of a product, 4x cubed times the log of 3x squared. So we're going to take the first function, 4x cubed. The derivative of the log of 3x squared is 1 over 3x squared plus 1 times the derivative of 3x squared, which is 6x. Plus the log of 3x squared plus 1 times the derivative of 4x cubed, which is 12x squared. Now on this side we have 24x to the fourth. So we can factor out a 12x squared and end up with 2x squared left over here over 3x squared plus 1. And on this side, the 12x squared has come out, and we're left with the logarithm of 3x squared plus 1. So we have to still deal with the 1 over y factor on the left. So we multiply through by y of x, and this was the original y of x, 3x squared plus 1 to the 4x cubed. So we end up with 3x squared plus 1 raised to the 4x cubed power times 12x squared times 2x squared over 3x squared plus 1 plus the log of 3x squared plus 1. Please consider subscribing to our channel. We will have more math and even physics videos forthcoming. Some already up, and we will be adding them as time goes on. Thank you.